Good afternoon, everyone. So just before we get started, I just saw a tweet on the wall. Someone called us entertainers. We resent that.
We are, in fact, exotic dancers.
All that. There's something with you. Why do today you want to be naked first and then you want to dance? That's wrong.
It's the new me. Nude.
So hi, I'm Romain Guy, formerly from the Android team, and this is Chet Haase, still on the Android team. So a few days ago, weeks ago, I don't even remember, we announced, or they announced, Android 4.4 KitKat, and this is what we are going to talk about today. So this is what's new in Android. Before we get started, we're going to give you, we're going to talk about a few numbers, and we're going to talk about the new device that just came out, so the Nexus 5. How many of you have a Nexus 5 with them today? I love you guys.
I would like to point out that the slides aren't actually drawn to scale, so
it is a big phone.
To be a little more realistic. Right, we believe in truth in marketing.
All right, we won't bore you with the technical details. If you want to know more about the Nexus 5, you can probably Google it. Chet?
Yes? Big numbers. I like really, really big numbers. Numbers with lots of zeros behind them and no decimal points. 1 billion devices. So, huge number of people with Android devices out there. Not only that, but the rate at which it's growing is amazing. What was it last year? There were 500 million. I was about to say 500,000. That would be a huge growth rate. So 500 million up to 1 billion in a year, and by our calculations, in 4.5 years, everyone on the planet will have an Android device. It's just math, people.
That's or you are all insane and you buy way too many phones.
So this is the growth rate over time over the last, 3 years here as people get more and more Android devices. Huge, 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 which is good for you. I assume most of you are Android developers actually trying to sell your applications, or
actually,
you
how many
fell
of you
asleep in the
are
previous
Android
talk.
developers? Okay, some people are not raising their hands, so what are you
Sleeping.
Okay. This is not about web, this is not about Java 8, this is not about JavaScript, it's Android. So more importantly for developers, these are the current numbers, the repartition of the API levels. So these are taken from access to the Play Store. So this is people actually going to the Play Store to download applications. And as of today, 52% of the user base is running on Jelly Bean. Gingerbread still counts for 26% of the market. And as you can see, there's Honeycomb. I don't even know why I bother putting it on the slide, because it's 0.1%. I don't know why those people are not updating their devices, because pretty much every Honeycomb device was updated to ICS.
Not my Zoom. That is my Zoom, right there.
Yeah. Yeah, that's true. I still have a Zoom. And there's a sad few for your devices that are still going to the Play Store. Now, if we gather this data, we can see that if you target API level 15 or higher, so that's ICS and Jelly Bean, you can capture 72% of the market, and you can benefit from all the really cool APIs that we've introduced since ICS. Now, we're going to talk about the new features for developers that we introduced in KitKat. The first one of them is the Storage Access Framework.
Documents, a unified way of accessing document and accessing storage on the device, as well as a way for you to advertise the storage that you would like to be made available to developers in a unified way. So it's sort of both sides of the equation. How can users get to all of the storage mechanisms on the device? And it's how can you expose your storage mechanism, something in the cloud, something locally, whatever, in a way that that integrates with the user experience on the phone. And
this is what the UI looks like as a user. When you use an application that's taking advantage of the new API, you're going to see this new document chooser. And if you look closely, right under downloads, there's an item called internal storage. This item does not exist by default. If you go in the settings, so if you open the overflow menu and you go in the settings, you can turn that on, and that will give you access to the file system. So, if you're interested in finding a very specific file on your phone, you don't need to install a file explorer anymore. You can just do it through this UI. And of course, your application can participate in this new UI. So first, if you want to bring up that UI, you can use the new action open document intent. And you can specify the MIME type. So if you want to be able to just choose an image to attach it to an email, for instance, you just say images/star, and you add the category openable. There's another intent called action create document that can also bring up that UI and that can invoke other applications. If you want to provide files, documents, sorry, if you want to provide documents through this UI, you can extend this new documents provider. So the documents do not have to be backed by files. On the screenshot, you saw the example of Dropbox or Box.net. So you can have the files in the cloud, and you can use the new provider to get access to the files without having to sync them on the device. So these are the 4 main methods that you should override if you want to provide documents. The first one is query root. It just returns the list of top-level documents in your store. Query child documents is pretty obvious. It's going to give you the children of a given root and subfolders. Query document is just to search documents. And the last one is the most important one, open document. This is how you give access to the actual content of the document. So we use a parcel file descriptor that will contain a file descriptor. And we do it this way so you don't have to open a stream to an existing file on the device.
So these are the basic functions that you need to implement to get access to files, but then there's other ones that you can choose to implement, such as create document for actually creating documents through your provider.
And there's something interesting. If you look at the open document method, we pass a cancellation signal, and you should try to take that into account. This allows the user or the calling application to cancel the opening of the document at any time, but you have to use that signal object to react to the event, to the cancel event. Once you've created your provider, all you have to do is to declare it in your manifest, and you simply need a new intent filter, the filter documents provider. You need a new permission also called manage documents, and don't forget to export your provider.
New printing capability. Wouldn't it be nice to be able to print from your Android phone? So we added printing services on the device and the ability for applications to opt into this and then write a little bit of code to basically generate a PDF document that can go to any Cloud Print-enabled device in the network.
So on Nexus 5, here you can see a screenshot taken from an actual device. We ship with 2 plugins, so we support the Google Cloud Print, and we also have a plugin for HP printers, which was lucky for me because I was at home when I took that screenshot, and I happened to have an HP printer at home, and I was able to print my flight tickets on that printer, and it worked. I was pretty amazed. It's pretty awesome when our software works. And the picture on the right, the screenshot on the right shows you the UI that you're going to see when you actually print a document from an application. Something that's very interesting about the printing framework is that it's all based on PDF, which means we are exposing APIs to let you generate PDFs. So this is the kind of code that you would write to generate a PDF document. So you just create a new PDF document, you create a new page, and for each page you're going to get a canvas object. So any piece of code that you have in your application that can render onto a canvas, be it custom drawing code or a view, we'll be able to render onto that canvas, and we're going to generate the PDF from that. So when you're done, you can just write the document out to an output stream, so you can send it off, to a remote server or just on the file system.
So if you look at the piece of code in the middle that says content.draw, that's basically going to bottom out, depending on how you implement things in your application, in the standard drawing that you do, either in custom views that you have or the views that we have. That's just basically you draw to canvases just as you normally would. Or you may want to customize it for the actual printouts.
So what's nice is that if you want to quickly add printing capabilities to your application, you don't have to write a lot of custom code. You can just draw your content view, whatever is the main view in your application, directly to the PDF document, and then we're going to print that. It can become a little bit complicated when you have a lot of content. You need to start dealing with margins and multiple pages. So we have a helper class that you can also find in the support library called the print helper. And for instance, if you want to print an image, we make that very easy. You just decode your bitmap, or you get it from, or you generate yourself from code, and then you call a single method called print bitmap. You pass the bitmap, and we're going to take care of the rest for you. For simple cases, you should just definitely take a look at the print helper.
There were a bunch of changes in the user interface, graphic system, and other areas. Let's talk about some of those. So this is more of a user-level feature that you'll notice on the device, but you can opt into it in your applications as well. So if you look at the launcher, if you notice the top and the bottom of the screen, you'll actually see the wallpaper through the navigation and
Status bar.
Status bar. Oh, words fail me. Okay, so you can opt into this as well, and you can provide that same translucent support so you can see through to the content of your background window or the content in your application. And the way you would do that is by using the following themes. Translucent decor, yes?
Yeah, so if you have custom themes, there are also theme attributes, style attributes that you can set in your own theme. I don't really remember the exact name, but you will find them in the documentation in the release notes. So you do not have to use the default holo themes. You can create your own.
And you can also tell us whether you want the content actually under there, or let's say you have an application window that you want to expose, like the wallpaper we wanted to expose, but we didn't want the icons on the launcher to actually be sitting under the navigation and status bars because that would be silly. So instead we told the container that contained the icons that it wanted to fit the system window so that it would not actually spread out to the full contents of the window and underlie the translucent bars.
And in a single application, you can decide to put elements behind the status bar or not. For instance, in the new launcher on Nexus 5, by default, all the icons, the shortcuts, the search bar will be under the status bar and above the navigation bar. But if you scroll to the left to the Google Now screen, you're going to see that the Google Now screen extends behind the status bar and the nav bar. So it's really up to you. It's whatever works well for your UI design.
There's a new immersive mode. To some extent, we offered this before, but we offered it in a very limited interactive way. That is, you could opt, if you had a video playing application or a video game, you could opt to hide everything and get a full screen experience, but as soon as the user tapped the screen, the navigation bar would come back in because we always want the user to be able to navigate away from the application or somewhere else on the system. I'm sure your game is lovely, but maybe the user wants to do something else. So that was handy, but not really what you need, especially in an immersive experience like a 3D game. Wouldn't it be nice if you could actually make the controls go away and stay away until the user actually wanted them on the screen? So that's what the new immersive mode is all about. So there's a couple of flags that you care about here. One of them is the system UI flag immersive, and this starts this experience where the system bars will go away, and only when the user does particular gestures, which is basically swiping down from on top or swiping in from whichever direction the bars went away from, depending on the orientation of the device. So they can always swipe down from on top, and then the bars come back in, and then they can interact with the system itself. Until that point, they're just in full screen mode in the middle of your application. So that's the immersive mode. There's also one other mode that we'll see in a minute. This was the standard one, right?
So yeah, these two pieces of code show you that you can programmatically control whether or not you want to see the navigation bars. So if you set this, that's a lot of flags actually, but if you set all those flags, you're going to hide the entire system UI, and if you want to bring the system UI back, you have to set these flags instead. It's pretty simple. If you go look at the documentation of those various flags, there are a lot of explanations. You should really take a look at it to understand what every single one of those flags does.
And there's one other flag that you would care about for this new experience is the immersive sticky. You can choose whether, when the user brings those bars back in, whether the bars stay on the screen until you programmatically send them away again, or whether they should automatically go away after a few seconds of non-interactivity with the system bars. And that's the sticky flag. If you say sticky, then basically they'll go away automatically after a few seconds.
So this means that on Android we have now 3 different ways of going full screen, and we just want to give you some guidelines on what mode you should choose depending on the application that you're writing. So if you use the flags full screen and hide navigation, it's really meant for non-interactive applications like a video player. So this is what was used already in applications like YouTube or the default video player on the system. And it's what we call the lean-back experiences. If you use the full screen flag, the hide navigation flag, and the immersive flag, that's typically for content, rich content like a book or magazines or maybe an RSS reader, but you still want the user to be able to bring back the system UI and stay there. So typically in the book application, you're reading your book, it's full screen, it's great, but when you tap the middle of the screen, you want to bring the system UI back because maybe you want to change the font size or you want to go buy another book. So you want the bars to stay where they are until the user is ready to make them go away again. If you have a highly interactive application, typically a game or a drawing app, instead of the immersive flag, you're going to use immersive sticky, because if the user brings the bars back, they will disappear again on their own after a couple seconds, bringing them back into that immersive, highly interactive experience. So it really depends on what you're doing in your application. Play with the different flags and see what works best for your app.
There's a new web view. which is based on Chromium. So now we've standardized on same source base that that Chrome uses itself, or Chromium uses. I forget the official term.
Chrome is based on
Chrome
Chromium.
is based on Chromium. That
And
was
the web view is
official
based on
term,
Chromium.
yeah, right. So using the same code, good thing, reuse, right? And better adoption of standards, leading edge stuff, tracking the development of the web standards much better. So that is now the default, the only option for WebView. So go ahead and try it out.
Yeah, you should make sure to test your applications on Android 4.4 because there might be different behaviors, there might be bugs, there might be regressions. If you find any issue, please file a bug on the external Android bug tracker or maybe even the Chromium bug tracker. The Chromium team is really responsive and they've done an amazing job at fixing a lot of bugs that we encountered during the development. One of the benefits of Chromium, of course, is better support for HTML5. But it also brings a whole set of really good development tools for you guys. So if you have a web view in your application, you can now enable debugging. So here I'm just using the build-config.debug flag that's generated by the build system to turn on debugging only when my app is in debug mode. And that lets me open Chrome on my desktop. And if I visit this URL, so chrome://inspect, and I have my phone hooked up to my laptop over USB, I can now use the Chrome development tools. So this is one of the development tools in Chrome. This is the profiler. You can use the JavaScript debugger. You can use the HTML DOM inspector. You can modify CSS. So you can directly interact with the content of your web view from your desktop or from your laptop. And this is going to make development of web-based applications, of HTML-based applications on Android much, much easier. Before, you pretty much had to write your code on your desktop, package the APK, test on your phone, try to figure out what the hell was going on, and then do it all over again.
Ooh, new animation APIs. I like this one because I like this one.
So should I leave for the rest of the session?
Pretty much. I'll be about 30 minutes here. Okay, so I've always seen it as one of my jobs to make animations so automatic that developers don't actually have to think about them. They tend to get them for free, because otherwise they tend to not write the animations, which means applications are kind of static and dull and not as rich as they could be. In particular, it's nice if you can help the user understand the flow of your application as they go from state to state of that flow, right? If things are going away and coming into being and moving and resizing, it's nice to help the user understand what's going on in the changes of the UI. So we introduced this new system called Transitions, which is all about that. So we have a couple of different pieces of this. I'll try to help you understand what's going on here. First of all, we have scenes. This is basically the state of the UI, the state of some subset of the view hierarchy at any given time. So this is, you can think of it as equivalent to a layout ID or some portion of a layout ID. You can create a scene from a scene root saying this is the hierarchy that I'm defining the scene on, and then when someone enters this scene, here's some code to run associated with it, and then that code would change the UI appropriately. You can also create a scene for a layout ID, and when that scene is entered, it'll automatically inflate the layout ID and then substitute it for whatever happened to be in that container to begin with. Or if you've already inflated that layout ID or otherwise created this container, then you can say, when you enter this scene, here's the view group that I want to associate with that scene. Transitions are another module, and this is basically the animation that takes you from changes in scenes. So when we're leaving one scene and going to another, transitions are responsible for detecting the state of the objects in the original scene, the state of the objects in the scene you're going to, the differences between them, and then creating animations that animate those differences. If things come into being, if things go away, they're fading in, they're fading out. If they're moving and they're resizing, then those changes will be animated. So basically animating the layout changes that happen between those scenes. That's the default behavior, and then there's also the ability to customize that behavior if you want. The two transitions that come in particular that you may use and which come automatically for default transitions are change bounds, which changes the location as well as the size of objects, and fade, which obviously fades things in.
Actually, someone yesterday told me that he looked at the source code of the platform.
Why would he do that?
Yes, I know. And he found transitions that are hidden.
There are some hidden transitions because there was some other work that was going on that was not quite ready for prime time. We have this awesome tag that we use called @hide, which is for API that either we're using internally or which we're currently working on, but is not quite there yet. So if you want to see how to write your own transitions, you can certainly take a look at some of the hidden transitions and see what was going on.
So what are the other transitions? There's
that were hidden?
Yeah.
There's a colorize or a change color. I can't remember the name. There's a change text. There's I can't remember. I don't know. There was a bunch of them I was working on. There's a crossfade. There is a crossfade, which is useful. All of them have their weird eccentricities, which is why they're not public yet. Transition sets, this is sort of the equivalent of an animator set or an animation set. It allows you to create more interesting, complex choreographies of transition. I want to fade in the objects that are coming into being, and then I want to resize things or other groupings as you see fit. You can nest transition sets, so you can have things run in parallel and then other things run in sequence, all in the same overall transition. And finally, you can create transitions from XML resources simply by declaring things associated with their names. You can create this transition set that has these couple of separate leaf node transitions inside of it. You can tell it the ordering, whether you want these things to run in parallel or sequentially. And you can create custom transitions. There's 3 methods that you care about in subclassing the class transition. There's capture start values and capture end values. Capture start values is called when we detect that we need to run a transition because we're going to make a scene change. And that's the point where you record all the information that your subclass cares about, the rotation property in view, a translation property, whatever it is that you want to animate. And then we'll call capture end values when we've gone to that end state. Then you see what the values are there, and then finally we'll call the create animator method. And that's the point where you compare the values, create the animator that you want, return that, and the system runs the animator appropriately. Transition Manager is the final module that you might care about if you have a more complicated application where you're going between several different scenes and you want to carefully choreograph different transitions that happen depending on what the scene changes are. Then you can create this tree of dependencies and say, okay, when I go from scene A to scene B, I want you to use this transition, scene B to scene C, I want you to use this other one. So you can create a transition manager either in XML resources, as shown here, or you can create it in code by saying, I want a new transition manager and I want to add the following scene and transition information to it. There are different ways to actually go into scenes. The first one that you see, this won't trigger an animation at all, not terribly interesting, but if you just want to go into this scene that you've defined, you can say enter this scene. If you actually want to run one of the transitions, either a custom transition or a default transition that just animates things magically, you use one of the static methods in Transition Manager to say go into this scene, then it'll find the appropriate transition and run it. Or if you created this more interesting tree, this graph of transitions and dependencies, then you can use that to say, okay, pick the most appropriate transition and use that in going to the following scene. Or all of this was leading up to actually just one line of code. This is the easiest way to use the transition system. Right before you're going to make all the changes that you want to your UI, if you want to do this dynamically in code, you're going to resize elements, you're going to add views, you're going to remove views. Right before you do that, you say begin delayed transition. This is a key to the transition system to go off and record the current state of the tree, and then it waits for you to make the changes. It'll get a callback on the next frame, and at that time it records the end state information, compares those states, figures out the deltas, creates the animators, and runs the animation. So basically one line of code to add quick and easy animations to your application.
Yeah, so if you want to quickly add those animations, you can go in your existing app, find places where you add views, remove views, change the size of different elements. You just add that line of code. You can protect it with an API level check, and you're done. You're going to get beautiful automatic animations. Can you pronounce that slide, please?
This is I11Y, A11Y, and I18N something. Yeah.
Not helpful.
Accessibility in I18N.
Thank you.
All right.
So one of the new features in Android 4.4 for users is in settings. We now have system-wide settings for closed captioning. So if for various reasons you need closed captions because you don't want to bother people around you, so you want to turn off the volume on your phone, or if you need them because you can't hear too good, you can now go in settings, then captions, and you can choose your locale, your preferred locale for the captions. You can choose the text size, you can choose the color of the text, you can set drop shadows, the background color, and all that. What's really interesting is that we make all those settings available to applications, and I'm going to show you the API you can use if you write video players to honor those settings. If you use a video view, we're going to automatically look at the settings and apply the settings to the video. And you can supply subtitle sources to your video. So it uses the web VTT format, and if you're doing HTTP live streaming, the subtitles can be included in the stream, and you don't have anything to do. If you're playing the video from a different source, or if you want to specify your own closed captioning sources, this is what the code looks like. So in this example, we're adding 2 different sources, one for English, one for French. It's very simple to do. You just open raw resources and you specify the locale for each one of them. Now, if you're doing custom rendering a video, if maybe you're doing a game or you're doing custom OpenGL code to do video processing, you can use the new Captioning Manager API to get access to the style that was chosen by the user. So for instance, here, we're getting the user style, and from the style, we're getting the typeface. You're also going to get whether or not drop shadows are enabled, the color of the text, and so on. What's very important on the Captioning Manager is to register a listener, and the listener will tell you, will notify you whenever the settings have changed. So that can be toggling the captions on and off, or changing one of the settings, the color of the text or the font.
We'd enabled auto mirroring for drawables. So previously, if you had drawables in your system that you wanted to enable RTL for, right to left for, then maybe you would need to supply 2 different drawables. So you're basically bulking up your APK just so that we use the right image for when we go into RTL mode. Now, for some of your drawables, if they're going to look the same right to left and left to right, then you can tell us that. You can use this new flag and say, hey, this one is auto-mirrored. And that means you can just have that one asset that you provide, so it takes up less space in your APK, and then we can just flip it on the fly, or know that we can just draw it as is.
So this is an example taken from the source code of the platform itself. So instead of duplicating over our drawables, we kept the size of the framework jar file pretty small, but just using the new auto-mirror flag. You can also use it from code, so on any drawable, you can set the auto-mirrored property to true. And how many of you have ever tried the application in right to left mode? Ouch. You are terrible people. No, sorry. It's pretty hard. So one of the things is it's very important to provide applications that support right-to-left locales, because there are several hundreds of millions of users in the world whose primary language is written right-to-left. The problem is that if you don't speak Hebrew or Arabic, for instance, it can be pretty difficult to navigate the Android system when everything is written in an alphabet that you can't even read. So in 4.4, we have a new development setting. So if you go to developer options, there's a new item called force RTL layout. And when you turn that on, we're going to force the system to be right to left, but we're going to keep your current locale. So this is the settings in right to left, but using the English locale. So you can navigate the system. You can look at the apps that come with the system. So you can look at settings, the navigation bar, the status bar, launcher, maybe Gmail. All those apps support RTL natively. And you should take a look at them in this right-to-left mode to see what they look like, what an RTL application is supposed to look like. Then you can go try your app and see if it behaves properly. It's actually very easy to add support for RTL in your application. And I believe that in Android Studio, we even offer refactorings that will automatically try to convert your layout files to do the right thing in RTL. And most of the time, all you have to do is find all the places in your layout files where you say left or right, for instance, margin left, margin right, padding left, padding right, and replace them with start and end. So margin left becomes margin start, and margin right becomes margin end. And that's all you have to do.
So one of the things that we think about a lot in the framework team in general and the graphics team is performance, because wouldn't it be nice if we could run faster and smoother all the time? We're a lot better than we used to be, but frankly the requirements are ever increasing on the system. Higher resolution displays, applications wanting to do more, UX teams wanting to do more. And so we keep working on this performance thing and probably always will. So there were a few items that we worked on in the KitKat release that we wanted to talk about, making things better in general. One is reusable bitmaps. This is actually a feature that we enabled in 3.0 at the same time as we moved the allocation of bitmap memory from native up into the Dalvik heap. That necessitated that if we want to get that memory back to allocate it to some other object, then we need to do a full GC. So at the same time, we enabled the ability to reuse memory for bitmaps. So you can create a bitmap of a certain size and configuration and then just decode other bitmaps into that same buffer This helps out the GC situation tremendously because that means it doesn't need to collect the original object in order to decode and allocate the second object. So that was great, but it was extremely limited. You had to have an image of exactly the same size and configuration as the one that you wanted to reuse. So what we did in KitKat was enable a much more flexible system in which you can have a scratch buffer that is at least as large as the buffer you're going to need to hold the same number, to hold the number of bytes required for the next bitmap. So you can change the sample size, you can change the configuration, the width, the height, none of that matters. Instead, you basically just have this sandbox that you can decode things into. This is really useful for applications that are loading large images off the web and they just want to put them somewhere as they then sample them down to the size that they need, or if they're just going through thumbnails, if they're scrolling through temporary objects really quickly. It's an efficient mechanism to avoid doing more GCs than is really necessary for these temporary objects.
So in this example, we are first creating a bitmap that's 1024 by 1024 pixels wide and only 1 pixel high. And using the configuration alpha 8, so that's 1 byte per pixel. The dimensions were chosen so that it's easier to read. We're basically declaring a bitmap that uses 1 megabyte of RAM. And then we call the reconfigure method. You can also use set width, set height, and set config. And we're telling the bitmap that actually we want it to be a 256 by 256 ARGB 8888 bitmap. So that's a 4 bytes per pixel bitmap. That's a lot smaller than the megabyte that we just allocated. And we can verify that by calling getByteCount. That tells you how many bytes the bitmap is using in its current configuration. But there's a new API called getAllocatedByteCount that will tell you the size of the actual underlying storage. So you might be wasting a little bit of space, but it also means you can pre-allocate bitmaps that are as large as you'll ever need, and then reuse them for all the different sizes that you actually use during the lifetime of your application. So here's a more practical example. You can use that with the new bitmap factory. So you create your scratch bitmap. So here again, we allocate a 1 megabyte bitmap. And we declare, and before we decode, we create bitmapfactory.options. And those are very useful. You can do a lot of things with bitmaps at decode time. But here what we're doing is we're specifying our scratch bitmap as the input bitmap. So we're telling the bitmap factory we want to decode the new bitmap in that existing bitmap. And the only rule now is as long as the source bitmap that we're providing is big enough, the decoding will succeed. There's also a new feature. If you specify the sample size, we can resize the bitmap while we're decoding it. So this is really fast. It's going to use less memory, and it's a very efficient way to deal with bitmaps. This wasn't supported before because the source bitmap that you provided had to be of the exact same dimensions as the bitmap you are decoding. And finally, you just call one of the decode methods, and you specify the options instance. Something else that we've done in Android 4.4, so this affects all of the applications that do UI. There's no new API. It's really optimizations behind the scenes to make your applications perform better and be a lot smoother. So it's something called the shared assets texture or the assets atlas. So how many of you are familiar with the concept of Zygote on Android? Okay, not very many. So when you boot an Android device, one of the first processes that we start is something called a Zygote. And in the Zygote process, we preload all the classes. So we preload the most commonly used framework classes. We also preload most of the assets that come from the framework. So for instance, buttons. Buttons tend to be used in pretty much all applications. And the button is made of a lot of images. So we have the normal state, we have the press state, the disabled state, the focus state, and so on. So we preload all those images in Zygote, and that way, everything we load in Zygote can be shared across all applications. So when you start an application, we don't start a fresh new process. We fork the Zygote, and we can share all that data. And typically, we share maybe 15 megs or so of data. So it's a huge memory optimization on Android. Now, one of the problems was with the hardware acceleration. When an app needed to draw a button, we would take the button from the Zygote and make a copy on the GPU. So we were creating an OpenGL texture, but every app was doing that. So we were wasting memory, we were wasting time. Every time we were starting an application, we were doing the upload. And every single framework asset was treated as a different texture, and we'll see why that was important. So now what we do, the first time you boot an Android device after you got an update, we run through thousands of different algorithms to pack all those assets together in a single texture. We find the best one for your device. And then we create an image that pretty much looks like this, and we copy it on the GPU. And then we share that GPU texture with all the processes. So what we've done is saving a lot of memory. So every process is saving from a few hundred kilobytes to maybe a megabyte of memory. And when you have 20 or 30 processes running on the device, that adds up pretty quickly. But the main advantage is due to the reordering and merging feature that we introduced in Android 4.3. How many of you are familiar with that optimization? We talked about it at Google I/O, so not many of you.
So all the Google I/O talks are online. If you want to know more about graphics performance stuff, including the details in reordering and merging, there's a YouTube playlist for the Google I/O talks. So
a quick description, the way you declare a UI on Android, so when you declare your layouts, is really inefficient for the GPU. If we just draw everything in the same order that you've declared them, it's going to be, we're going to waste a lot of time doing that. So what we've done in Android 4.3 is at draw time, we take all the drawing commands that come from the app and we change their order. And once we've changed their orders, we try to batch everything together. So all the text will be drawn at the same time, all the buttons will be drawn at the same time. Then we try to merge all those commands. So if you draw text 10 times on screen, it becomes a single drawing command for the GPU. But we can only batch and merge commands that were coming from the same texture. But now that all of our assets are in a single texture, we can merge all the assets together. So this is a little video that shows how we render the settings UI on a Nexus 7 on Android 4.4. And if you look closely at the beginning when we draw the checkboxes, you can see that in a single draw call, we draw the unchecked boxes and the checked checkbox together, and that's because they come from the same texture. So instead of drawing, the checkboxes one by one, we can draw them in a single pass. And you can see the same happening for text. We just do true draw calls because we have two different fonts, and that typically saves a lot of time when rendering frames. And we were able, with this technique, we were able to save maybe to make Gmail on Nexus 7 about 17% faster. So you don't have to do anything in your application. Things just got better. A few more optimizations that we introduced, something called a software vsync. I won't go into too much details because it's complicated and I don't myself quite understand all the details about it. But basically the idea is so we have vsync, we've had vsync for the rendering system since Jelly Bean, since 4.1. But now we basically lie about the vsync to the framework, and we start doing the work a little bit ahead of the actual hardware vsync, and that reduces latency. So that makes touch interaction feel a lot better. Surface Flinger, the window compositor, is now written in OpenGLES 2.0 instead of OpenGLES 1. And it's an optimization, but it opens the door to many more optimizations and also possible new features in the future. So you could imagine a high contrast mode, or we could do colorblind modes for people who need it. We've also introduced asynchronous texture uploads that makes text a lot faster to render.
There were performance improvements in render scripts. In particular, they enabled GPU acceleration on a few different devices. I believe it's all of the Nexus devices from 4 on up. And we're working with hardware vendors to enable it for other devices as well. So RenderScript still performs well on other devices. In particular, it's able to scale across the multiple cores of the CPUs on any device. But now it can also scale across the GPU on devices and drivers that enable that capability.
Yeah, if you want to know more about RenderScript and get performance numbers and code samples, there is a talk this afternoon by Nicolas Rohard on image processing on Android, and he will talk quite a bit about RenderScript. But RenderScript is also available in the NDK now, and this is the kind of code that we use in the hardware render on the platform itself to render drop shadows. So we want to simply blur things. So there's a lot of setup code, but that's all you have to write, and that code is automatically multi-threaded on multiple cores, or it will run on the GPU if you have support for GPU. And by doing that, we basically replace our handwritten blur algorithm that was written in C and C++, and we replaced it with RenderScript. We're actually forcing it to run on the CPU in that case, and we got a 2 to 5x improvement by just doing that.
Systrace is a tool that was released in, I believe it was Jelly Bean, wasn't it? Which is A great profiling tool that shows you not just what's happening in your application, your process, but actually system-wide. And this is really helpful. It's been immeasurably helpful to us on the Android team, tracking down problems that are happening somewhere else in the system. But it's also good for application developers to understand what's going on in the system that may be causing problems with your application. So we did a deep dive into that yesterday. So there will be a video on that if you didn't go to the university talk yesterday. There were more capabilities added to systrace recently. There's a nice UI so you can enable the tracing flags more easily. There's also the ability to add application level tags, so now you can introduce code in your application, get more information from systrace integrated with the rest of the tracing information there as well.
We also have a new overdraw debugging tool. So how many of you have used the overdraw debug tool in 4.2 and high? Okay, that's not enough.
It tends to be a source of performance bottleneck, so it's a really good tool to use.
If you want to know more about that tool and why it's important and how you can use it, you can find, I wrote a lengthy article about it about a year ago on my blog, so if you just look for Android performance overdraw and my name, you'll probably find it pretty quickly. So the new overdraw debug tool is shown here on the screenshot. So now we will show you a number on every window that's on screen, and it tells you how many times, what's the level of overdraw. So here in Quick Office, we see 2.70x, which means that we've drawn the screen twice plus 70% of the screen on top of that. So usually you want that number to be hopefully at 1, but it will never happen in any useful app. But this number between around 2 or between 2 and 2.5, that means that your application is going to perform really well. If the number is higher than that, you should definitely try to optimize it.
So there was a lot of effort focused on making the memory smaller for the platform, providing tools to allow applications and the framework to do that, but in general, just trying to cram into a smaller space. And one of the reasons was the slide that we looked at earlier that looked at the numbers. It said there are still, what was it, 32%?
26%.
26% of the devices checking into the Play Store are on the Gingerbread release and before. Wouldn't it be nice if that number kept going down so that developers could take advantage of all the features in the Jelly Bean release and later? So the idea here is that those devices are maybe still being released because they have less memory requirements than some of the later releases. As we add capabilities to the platform, we've added the memory footprint of the platform as well. So running on a 512 meg device was sometimes problematic. So that was the goal, was to run current Android KitKat on a 512 meg device and have a similar experience as you would have on a higher end device with more memory available.
So to make it easier to track down possible issues with your applications in terms of performance, we have a new UI called Process Stats that you can find in the Developer Options category of settings. So this is what it looks like. So the first screen you're going to see is the one on the left. So at the top you can see it says background apps over 4 hours and 23 minutes. So that's that's how much time we spent sampling the running applications. It's telling us that the device memory is currently normal, so the device is not under pressure. We have plenty of RAM available. And that first colored bar at the top shows you how much time we've spent in different conditions. So red was critical, so that means we are really low on memory. Orange was moderate, and green is normal. So here the device was actually performing pretty well. Then we rank all the running applications based on the amount of RAM they're using. So you can see here, System UI is the one that's using the most RAM, and that's what that blue bar means. The blue bar is just a representation of how much RAM those applications are using. And the percentage on the right tells you for how long those applications have been running over the sampled period of time. So here, every app was running for 100% of those 4 hours and 23 minutes. If you tap on one of those applications, you're going to see the second screen on the right, so you get more details. So we have a different example here, the download manager. It was running for 52% of the sampled period. And you can see the average RAM usage and the maximum RAM usage over the sampled period. What's very interesting for you is that if your application is running a lot more than it should be, or than you think it should be, we will tell you why. At the bottom, you'll see a list of services. So here we can see what services caused the download manager to be running. So for 53% of the time, the download manager was running because of something called MTP service. MTP, this is what we use for file transfer, so that probably means that the device was plugged into a computer and the file transfer client on the computer was running. If you want to know more about how Android handles memory and what you can do in your applications to improve your memory usage, you can come to our talk yesterday. We spent an hour and a half talking about this really, really boring but very important subject that is Android and RAM. It will be available on partys.com, and we'll probably publish the slides on our blogs.
There's also an article on the Android developer sites that goes into more of the details about meminfo and procstats. And
go in the training section of d.android.com, and there's something called Memory and You or Android and RAM that will tell you everything you need to know. The UI we just showed you can also be used from the command line. That article explains how to read the output, so we won't go into too much details here. But if you want to run dashboards or if you want to have automated ways to track your memory usage, this is a good way of doing it.
A new API that we added along with SvelteWork was the ability to see whether you're currently on a low RAM device. So maybe you want to degrade the experience, use lower res images, something to allow your application to take up less memory and participate a little more usefully in the overall low memory ecosystem. Then you can query this new API on Activity Manager is low RAM device, and then implement your different logic there.
So now we're going to talk about connectivity in media. This section could also be titled when Romain and Chet pretend they know what they're talking about. So we're gonna be pretty quick. If you care about some of those features, you probably understand what they mean, and you can refer to the release notes and the API documentation. So first, that's one of my favorite acronyms.
It's by far my favorite feature in the release.
It's an acronym made of acronyms. So it's HOGP, which stands for HID over GAT.
Surely we can stuff another acronym in those 5 words.
In human being language, it means low power and low latency devices such as mice and keyboards.
They could have just said that, I think.
Yes.
IR blasters is the ability, if there's IR capability on your device, you could write an app that controls other infrared devices. You can write a remote.
NFC host card emulation, I was told by people who care about NFC that this is really, really cool and useful. And low power sensors. So we have we're going to batch sensor events to help battery life. And we also have new logical sensors. So we have step detection and counting sensors. So if your applications need that, you can be told when the user starts walking and how many steps they've been walking. The
low power, the sensor batching, as well as the step detection, depends on hardware and driver capabilities, and then we're working with partners on that. It's in the Nexus 5. I'm not sure of the other devices right now.
If you're doing video playback, we now support adaptive playback, so while the video is being played, you can change the resolution of the video, so this is very important when you're streaming video from a remote server and the bandwidth is not good enough. So you don't have much to do, you can just change the resolution on the stream itself, and we're going to seamlessly adapt the UI for the user.
Loudness enhancer.
Dude, you promised you wouldn't make that joke. So if you use the media player in your application, if you have several audio tracks, and in particular if you have dialogues, now you can control the loudness of different tracks individually, so you can make sure that the dialogues are audible. And I wish some of the movies I watch on my TV would do that. Image Reader, this feature has been requested for a long time. So Image Reader is a way to get access to the content of a surface. So the surface on Android is this object that we use to render pretty much everything. So once you have a surface, you can render with OpenGL into it, you can play a video into the surface, or you can draw into it directly. So when you create an Image Reader, you can specify the width and the height that you want, and then you can start rendering content, so like playing a video on the surface that's given to you by the reader. Every time an image is available, we're going to invoke a callback, and then from that callback, you can get access to the image data. So if you want to do video processing frame by frame, this is a way to do this.
Oh, and this one, next to HOGP and transitions, this is my favorite feature, screen record. So this is a very useful feature for debugging. It's also useful for external developers if you want to show a tutorial on how to use your app. We still use high-speed cameras for some debugging stuff to capture what's actually going on the screen. But this makes it far easier for most situations. You can simply run screen record, A to B shell screen record, tell it where to store the file on the device. It can record up to 3 minutes of video at a bit rate that you specify, and it'll capture every single frame down there. Then you copy the file up, and it's something that you can play in QuickTime or whatever your movie player is of choice allows you to get a really easy way of seeing what was actually happening on the device. For animation debugging, it's been immeasurable, but it's also useful for tutorials, teaching people how to use your app.
And if you don't feel like doing it from the command line, you can use Android Studio. It took me a while to find that button. I was looking for a record button, and I was probably silly of me because that button looks like a play button. So if you click on that play button, it's not going to play anything. It's going to record something.
Some of the icons in the tool have the look of being produced by an engineer that needed an icon and didn't have a drawing tool. So they got copied from something else.
Or they do what I've done for those slides. You just try to reuse existing icons and make them look like they belong where they are. So when you invoke the tool, you can specify the resolution, but you don't have to. By default, we're going to record at the resolution, the native resolution of the device. You can also specify the bit rate. So the default bit rate is 4 megabits per second. This is great for debugging, but if you want to produce a marketing video or a video that you're going to use on your Play Store page, I highly recommend that you increase that bit rate because we have a lot of gradients in our UI, and they tend to not work really well at that bit rate. So a few more things, especially that those
security, which is something that we know nothing about.
Security is important.
It's very important.
And
I agree. I like secure things.
We'll
SE Linux changed its mode setting. It's a proper term here. I wouldn't know. To enforcing. There's improved cryptographic algorithms, which means they're really far more complicated than I can discuss here. And finally, if you have multiple
elliptic curves,
elliptic
makes you feel smart.
Elliptic conversations. If you have multiple users on the device, multi-user was enabled in Jelly Bean.
Jelly Bean, yes.
I think Jelly Bean. Then you can now have VPN per user, which is probably what you want, since maybe your child didn't need corporate access to your account.
Who cares about security here?
Yay!
Again, why some people don't raise their hands? I don't get it.
Or give this slide instead of us.
Yes. If you know what we're talking about, please come on stage. So if you download the latest version of Android Studio, you're going to be thrilled to hear that it supports new language features, the first one of which is the diamond operator. So now you don't have to repeat that generic definition on both sides of an assignment.
It's about conservation of character space. Those lines were just simply too darn long.
It's going to make your source code a lot smaller.
Switches on strings. I'm sure you've seen this before. That's handy to have. Auto-closable?
Yes.
Okay.
Automatic resource management.
There you go.
If you have a class that implements the auto-closable interface, you don't have to call the close method anymore on it because usually it was for I/O operations. So you do a try-catch for all the I/O operations, and then in the finally block you would call close, but close throws an I/O exception. So in the finally clause of your first try-catch, you have a try-catch, and it was really silly.
And it's a mess. So this is an important feature because this is the only one of the language-level features that's that you need a target SDK, a target API level of 19 for. The rest of them are actually syntactic sugar. The Dalvik can compile down to whatever you need on previous platforms. This one you need target SDK 19 for the underlying platform capabilities.
Another pretty cool language feature is multi-catch exceptions, so you can catch several exceptions at a time without catching the base exception class, which is pretty good practice.
So the tools guys asked me to remind people that if they want to use this stuff, at least on the Mac, you need to get the most recent copy of Android Studio as well as making sure you have the most recent platform version installed that has some of these capabilities on it.
There's a new developer option to let you enable a new runtime. It's called ART. It stands for Android Runtime. We're really good at naming things on Android.
Acronyms.
Yeah, we have the Android Studio, we have Browser, we have Android Runtime, and we have the Android Framework. So we need some help, I think. Anyway, so if you go to developer options, there's a new select runtime item, and you can choose between Dalvik, the runtime you already know and love, or you can use ART. So ART is a little bit different, so if you enable it, you're going to have to reboot your device. And it's based on ahead-of-time compilation, so it's going to reprocess all the APKs on your phone. It's going to take a little bit of time. And by no means you should be using ART all the time on your phone if you do important things with your phone, like make phone calls or try to contact people. No, actually it works really well, but you should try your application, and definitely if you run into bugs, please file those bugs. The runtime team would love to hear about them. and you can see if your application performs better or worse, or just let us know.
There should be more information about that coming out sometime soon than you are learning today here from us.
And if you want to know more about some of those features, the DevRel team, the Android DevRel team, has come up with a series of Android dev bites. So if you go to this URL, it's a playlist on YouTube for all those videos, and you're going to see, like, so we have a 5-minute video on how to use the new storage framework API, 5-minute video on the new closed captioning stuff.
And transitions.
Of
and
course,
transitions. You want to hear me talk more about transitions.
If you're not sick of Chet, you can go watch videos of him online.
Chet to go.
God, that sounds terrible. Of course, if you want to know more, you can go check out the release notes. The first one is an overview, and the second one gives you a little bit more details about the new APIs. We have the API diffs, just like we do with every version of Android. So go take a look. Chet writes articles about Android. I used to. I don't know if I'll keep doing that, but you can go look at beautiful
There's a lot of
pictures.
good stuff on his blog anyway, so a lot of good historical stuff, including that. I would suggest that you check out the case study where he used the overdraw tool as well as a lot of the other performance tools to track down problems in a real application that they fixed, right? Didn't you send the information to the developer, they fixed their app, yay. But if you want to know how to use the tools in real-world situations, this is a lot of what we do on the framework team, so it's an interesting view into how to use the tools effectively for your
And
app.
you can also find us on Google+, where actually we tend to be more active these days than on our blogs. And we have 6 minutes left for questions.
For the flood of questions, there we go. Yes. There is, yes, there's support libraries, support for the storage framework APIs. I don't know the details of that, whether it supports everything, but I believe a lot of the stuff is in there, yes. That's a good question. Printing as well is support lib to some extent. Again, I don't know the full details. You might check out the dev bites on those for the details on that. Or, hey, just get the support library and see what's there. Transitions not in support library. Good question. Thank you for asking about transitions.
But we've kept that in mind for a long time.
Yeah, a lot of the early development on it actually happened outside the framework, just to sanity check that it could be done. There are some tricky bits that depend on platform capabilities, but the overall infrastructure should be possible. It's a matter of us getting the time to actually just go do the work, hopefully soon.
I
Can't hear you. Yell. Use your loudness enhancer.
Oh yeah, there's a microphone. Look at
Microphone would be good.
that. Is there a microphone? Yes, there is.
Will there be a multi-SIM API support, like dual SIM, triple SIM, but on the platform?
Multi-sync? Mike?
Dual SIM, like a SIM.
Oh, multi-SIM. I have no idea about telephony stuff.
What's multi-SIM? No, sorry. I have no idea. Maybe we have our friends from DevRel who are around here, and it's their job to answer your questions, so you can go find them at the Google booth.
Yeah, there are a lot of Google people, and several of them are Android Google people, so find them at the booth.
There's one right
for
here.
some
You can
questions.
grab him and ask him questions.
The guy with the funky hat.
Okay, no more questions? Yep.
For the storage API, is there a way how to restrict access
So for the storage API, is there a way to restrict access?
to the application, to the specific? For example, in our application, when you want to access the application, user can choose to enter a PIN code.
Okay, so can you restrict access to the documents, for instance, if your application requires a PIN code before you access the storage? I do not know that. Ask that guy, he's right next to you. Sorry. But that's a very good question. I know that Dropbox, for instance, you enter a PIN code before you can see your documents. I don't know how it works in that case. So with the new Chrome view, the new Chromium behind WebView, will you receive updates of just the WebView? No, the big issue with that is we want to keep behaviors tied to an API level. so that you can target, so you know that one API level corresponds to one behavior, and you can adapt your application based on the API level. I'm sure, and in the past we've pushed security fixes, for instance, but I don't think we're going to push new features or anything like that to the web view. All right, thank you very much.
Thanks.